We've built our understanding of the universe on two pillars: the vastness of space-time governed by general relativity, and the bizarre, tiny world of quantum mechanics. We think we understand these realms, especially around what physicists call the events horizon, where our theories feel solid. But what happens when those two pillars don't just wobble, but fundamentally clash? Something just happened at Google's Quantum AI Lab, something that sent shockwaves through the scientific community. It involves their cutting-edge quantum processor, a machine pushing the boundaries of computation, and a discovery so strange, so unexpected, it's being called the Omega pattern. And here's the part that's really freaking scientists out. This pattern, this mathematical structure, should not exist. Not according to classical physics, not according to our current understanding of quantum mechanics, not anywhere we've ever looked. It's appearing where it has no right to be, defying every expectation. Even renowned physicist Brian Cox, a voice often grounded in the tangible, has spoken out, suggesting we might be standing at the edge of a reality-breaking moment. Space, time, the very fabric of existence. This pattern seems to mess with all of it. So, what exactly did Google's AI find? Why is this Omega pattern causing such a stir? And why are some of the brightest minds on the planet genuinely scared by what they're seeing? Let's unravel this mystery, piece by piece. The story begins deep inside Google's quantum research lab, a place bristling with technology that feels pulled from a science fiction movie. At the heart of this particular discovery was Sycamore, their 53-qubit quantum processor. If you're not familiar, a qubit isn't like the bits in your phone or laptop that are either 0 or 1. Qubits can be both 0 and 1 at the same time, thanks to a quantum phenomenon called superposition. And when you link qubits together, they can become entangled, meaning they are fundamentally connected. Their fates intertwined no matter how far apart they are. This entanglement is key to quantum computing's power, and also, as it turns out, to this bizarre discovery. The Google team was running an experiment that, on the surface, seemed relatively standard for a quantum lab. They wanted to use Sycamore's immense processing power to simulate the absolute earliest, most chaotic phase of the universe, that fleeting moment right after the Big Bang. Think about it. Before stars ignited, before galaxies formed, before atoms as we know them existed. Just a roiling, unpredictable soup of pure energy and fluctuating quantum fields. To mimic this extreme environment, they programmed Sycamore to run incredibly complex recursive loops using entangled qubits. Imagine a feedback system where the qubits were constantly influencing each other, their states changing and interacting in a dynamic, unpredictable dance. The idea was to simulate the wild, fluctuating behavior of quantum fields during cosmic inflation, that mind-boggling period when the universe expanded exponentially, faster than the speed of light, in just a tiny fraction of a second. What were the scientists expecting? They anticipated randomness. Quantum mechanics, at its core, deals with probabilities and inherent unpredictability. They expected noisy data, maybe a few odd blips or anomalies. Perhaps something new that could help refine our theories about the early universe. That's the whole point of pushing these machines. But what they got was not randomness. Instead, they saw structure. Stable, repeating structure. A self-replicating pattern, emerging from pure chaos. It was like watching static on a TV screen suddenly resolve into a clear, repeating image. What they noticed wasn't just some random squiggle. It was clearly a pattern, and not just any pattern. It looked like it had a purpose. They named this unexpected structure the Omega pattern. Now this is where the story takes a seriously strange turn. The Omega pattern wasn't just a glitch, a temporary anomaly, or a static artifact stuck in one part of the data. It appeared across multiple parts of the quantum system simultaneously, in what physicists call non-local nodes. Imagine finding the same complex symbol appearing in completely unrelated locations across a vast network, all at the same time, without any apparent connection or communication between those locations. And no matter what the scientists did, they changed the input data. They tweaked the experimental conditions. They ran the simulation again and again with different parameters. The same pattern kept showing up. It was persistent, stubborn, appearing regardless of the starting conditions. Normally, if you're working with a computer, whether it's the laptop you're watching this on or a supercomputer, if something unexpected shows up, you can reset it. You clear the memory, wipe the slate clean, and start from scratch. In classical computing, resetting usually means you've erased whatever was there before. You have control. But with the omega pattern, after a complete reset of the quantum processor, the pattern came back. It re-emerged, almost as if it had a memory of its own, a determination to exist. At one point, the engineers, trying to understand this bizarre persistence, intentionally zeroed out the quantum registers, using every tool they had to ensure everything was erased, fully expecting the pattern to vanish. Instead, the omega pattern re-emerged, and this time, it was even more complex. It was like it had evolved. There were subtle variations, more intricate detail, more layers than before. Think about that for a second. This isn't how anything we understand works. In classical computing, you dictate the outcome. The machine doesn't just decide on its own to bring back a deleted file, and not only that, but to improve upon it. It doesn't just get more complex or detailed after you try to erase it. But Sycamore, or whatever was generating this pattern, through Sycamore, did something eerily close to that. This is the point where scientists started to pay serious, chilling attention, because this is fundamentally not how these systems are supposed to behave. Brian Cox, capturing the unsettling nature of this discovery, described it as a possible first glimpse into the deep structure of reality. He even compared it to the holographic principle, a mind-bending idea in physics that suggests all the information about a 3D space might actually be encoded on its 2D boundary, like a cosmic hologram. If that principle holds true, this omega pattern might not just be a pattern in space-time, it might actually be the code behind space-time itself. And now, it's showing up in our machines. Let's just pause again to let that sink in. This is a structure that came out of pure quantum entanglement, a chaotic simulation of the universe's birth. There was no pre-programming for this pattern, no external instruction telling it to form or persist. And yet, it didn't just appear. It persisted, it replicated, and it adapted, even seemingly improving itself after being erased. That has major implications for our understanding of emergence, complexity, and perhaps even consciousness at a fundamental level. Lead researcher, Dr. Anuka Patel, described the moment the team collectively realized what they were seeing as surreal. She said it felt like discovering a hidden verse in a poem that's been sitting in front of you the whole time, completely unnoticed. The simulation runs lasted for hours, involving trillions of quantum state changes every second, an almost unimaginable complexity. And yet, through all that quantum chaos, the omega pattern just held on, stable and unchanging in its core structure. Each rerun, each attempt to understand or erase it, seemed only to reveal more intricate details, fractal-like structures, repeating within the pattern, repeating loops, a kind of internal logic that no one expected to find in a simulation of the universe's most chaotic moment. At this point, the results were too significant and too strange to keep quiet. The findings were uploaded to Archive, which is essentially the global bulletin board where physicists drop their big news before formal peer review. And almost instantly, researchers around the world wanted in. Labs from Switzerland to Singapore began trying to replicate the Google team's experiment, running their own simulations of early universe conditions using different quantum systems or computational models. And guess what? They found the same pattern. There were slight differences, as you'd expect depending on the specific setup and technology, but the core structure, the fundamental omega signature, was undeniably there. This wasn't a fluke, a bug unique to Google's Sycamore. This was something deeper, something repeatable. Now, besides completely blowing open new questions about the fundamental nature of physics and reality, this discovery also opens the door to some truly mind-bending real-world technology possibilities. Think about it. A pattern that resists being deleted, that reorganizes itself, and that improves its structure with each cycle, even after attempted erasure. That sounds like the stuff of dreams for quantum memory. Imagine quantum computers or networks where data isn't fragile but inherently stable and self-healing. This could lead to incredibly resilient, self-correcting quantum networks, or superstable encryption systems that are virtually impossible to break. Stuff that, until now, we've only imagined in theoretical papers or science fiction. But of course, for every incredible technological possibility, there's a darker, more unsettling question creeping into everybody's mind. If this pattern is real, if it emerges from the fundamental rules of the universe, then why would the universe have a built-in structure like this to begin with? Some physicists are already whispering that the omega pattern might not just be a curious phenomenon we've discovered. It might be a signal, a code that was always there, woven directly into the quantum fabric itself, something that's only become visible now because we've finally built the tools advanced enough, like Sycamore, to see it. And Sycamore just saw it. But what if this isn't just a pattern to be observed? What if it's something active? What if it's a countdown? Countdown or code? Exploring the theories at first, the scientific community was largely captivated by how the omega pattern showed up and how it held its shape against all attempts to disrupt or erase it. Its sheer resilience was the main mystery. But then a chilling theory popped up from a physicist who had been studying the behavior of the pattern over longer simulation times. The idea is this: maybe this thing isn't just a discovery, a static feature of the universe we've finally spotted. Maybe it's a process, a ticking clock, not a passive observation of the universe, but a process within the universe, with a destination, an endpoint. That kind of thinking changes everything. It shifts from looking at reality to wondering if reality is doing something. As more researchers got involved, digging into the data and proposing explanations, the theories started stacking up. And let's just say, no one is on the same page yet. The debate is intense, fueled by the sheer weirdness of the pattern. One prominent group of physicists believes the omega pattern is essentially a quantum fractal. Now we see fractals everywhere in nature. The branching of trees, the shape of coastlines, the structure of snowflakes, the distribution of galaxies in the cosmos. They have this complex, layered structure that looks self-similar at every scale. You can zoom in or out, and the basic pattern keeps repeating. The omega pattern exhibits this fractal-like quality, showing complex, self-similar structures within itself. It also shows signs of what's called nonlinear symmetry. It's not a simple, regular pattern like a checkerboard, but it follows some deep, non-obvious internal logic. Some have compared its intricate structure to the famous Mandelbrot set, a wild, infinitely complex mathematical shape generated by a simple equation. The connection here is profound. If the omega pattern works like a quantum version of a fundamental fractal or the Mandelbrot set, we could be looking at a fundamental rule embedded deep within quantum field theory, a kind of universal scaling, law that governs structure at the most basic level. But then, another camp has a completely different view. They think this isn't just about structure, it's about function. They say the omega pattern might be a universal attractor. What does that mean? Think of it like a cosmic checkpoint, a state or structure that the universe naturally gravitates towards or checks against. It's something that keeps reality consistent, preventing it from completely falling apart into chaos. In computer science, we use checksums, little pieces of data generated from a file to make sure the file hasn't been corrupted during transmission or storage. If you recalculate the checksum later, and it doesn't match the original, you know something went wrong. This theory suggests the omega pattern could be the universe's version of that. A checksum built into reality itself, something that verifies. The quantum network, the fundamental structure of space-time, is still running smoothly, still consistent. Brian Cox actually chimed in on this idea, suggesting the omega pattern might act like an error correction signature. That's a fancy way of saying the system, in this case, the entire universe, might be self-aware, at least in the sense that it knows when something goes wrong, when some quantum state is corrupted, and attempts to fix itself, to restore balance. Except here, the system isn't a computer program written by humans. The code isn't something we designed. It writes itself, and it checks itself. Let's pause here again. A structure that appears spontaneously, checks for mistakes, restores balance, and shows up across different simulations no matter the starting point? That doesn't sound random. That sounds intentional. Not necessarily designed by a designer in the traditional sense, but perhaps fundamental to the universe's own operating principles. And then comes arguably the weirdest theory so far, retrocausality. This one doesn't just bend time, it turns it inside out. According to this idea, the omega pattern might not just be reacting to the past or the present state of the quantum system. It could be influenced by the future. Seriously, the notion is that quantum information can flow backward in time, and this pattern is pulling information from future states to maintain its stability and structure in the present. Yes, it absolutely sounds like pure science fiction, but labs in places like Japan and Canada are already running experiments trying to manipulate qubit states to see if they can send information or influence both forward and backward in time, specifically to see how it affects patterns like omega. And if that turns out to be true, it would actually explain a lot of the bizarre properties we've seen, like how the pattern keeps coming back, even when it gets erased. It's not just remembering its past state. It might be reaching ahead in time, grabbing its future, evolved form, and using that information to rebuild itself in the present. Brian Cox, always trying to synthesize these mind-bending ideas, posed the ultimate question. What if the omega pattern is the universe's built-in diagnostic system, a function that constantly checks its own structure, logs every little fluctuation, every potential instability, and keeps things coherent, preventing reality from unraveling? If that's the case, then reality isn't just something that happened with the Big Bang and is now just running its course. It's something that is being actively monitored and maintained, every single nanosecond. And here comes the part nobody really wants to think about. The part that ties back to the ticking clock idea. If the omega pattern is part of the universe's self-checking or self-organizing code, what happens when that process completes? What happens when the pattern reaches its final state, whatever its destination might be? Some researchers are now saying that if the pattern is indeed a process converging on a specific state, its completion might trigger a phase transition. That's a scary term in physics. It's what happens when something undergoes a fundamental shift in state, like water turning into steam or freezing into ice. But on a cosmic scale, if the omega pattern reaches a critical point, a kind of threshold, it might cause the underlying structure of space-time itself to shift permanently, like flipping a switch on reality itself, changing the fundamental rules of the game. And if that switch gets flipped, there might be no going back. And right when people were trying to wrap their heads around that terrifying possibility, something's even bigger happened. Something that threw gasoline on the fire of these already wild theories. Physicist Natalia Renova, working independently or as part of a collaborating team, the details are still emerging, dug deep into the simulation. Logs, not just the short runs, but the long-term data from simulations that ran for millions, even billions, of quantum cycles. She was studying the evolution of the omega pattern over these immense timescales. And she found that it wasn't just repeating or persisting, it was evolving. Very slowly, very subtly, over vast numbers of cycles, the pattern was changing, refining itself, converging on a specific, highly complex mathematical constant. And this wasn't just any number or shape. The value and structure the pattern was converging on was directly tied to specific equations from string theory, perhaps the most ambitious theoretical framework we have, attempting to unify all fundamental forces by proposing that the basic building blocks of the universe are tiny vibrating strings. Specifically, the constant and structure were related to what are called Calabi-Yau manifolds. If you've heard of string theory, you might know these are those incredibly complex, multidimensional geometric shapes that string theorists believe are responsible for curling up and hiding the extra dimensions of space that we can't perceive. In our everyday 3D world, that alone would have been enough to send the entire physics world into a full-blown spin. A pattern spontaneously emerging from chaos is strange. A pattern that evolves is stranger. A pattern that evolves towards a shape predicted by a highly theoretical framework about hidden dimensions? That's mind-blowing. But then, Renova did something that elevated this from a curiosity to a potential revolution. She cross-referenced this evolving omega pattern with old data, specifically data from CERN's Large Hadron Collider experiments back in 2012. The very experiments that confirmed the existence of the Higgs boson, the particle associated with the Higgs field, which gives other particles mass. These massive proton collisions generate incredibly complex data, a sea of signals and noise. Buried deep within that noise floor, completely unnoticed and unlooked for at the time, she found something incredible. The same pattern. The unmistakable omega signature. That discovery didn't just set off alarm bells, it sounded a deafening siren across the globe. Because now, this wasn't just about what Google's specific quantum processor happened to find in one type of simulation. The same pattern had been recorded in a totally different experiment, using entirely different technology, smashing particles together versus manipulating quantum states, more than a decade ago, from an experiment designed to find something else entirely. If this pattern is appearing independently in such vastly different contexts, it raises the possibility that it's not just a feature of quantum simulations or particle collisions. It could be universal. If it's universal, we might be able to detect it in other cosmic data we've already collected. Maybe in the subtle temperature fluctuations of the cosmic microwave background radiation, the afterglow of the Big Bang, or in data from elusive particles like neutrinos detected by deep-sea observatories. Finding it there would provide even more confirmation of its fundamental nature. But if it's not universal, if it only appears in certain high-energy physics experiments or specific quantum setups, then we have to ask a question that makes the hair on the back of your neck stand up. Who or what left it there? That revelation shattered a lot of theoretical walls. The idea that a single complex pattern could appear across disparate quantum processors, massive particle collision, experiments, and potentially be woven into the very fabric of the universe itself is unprecedented. It's like reality has been trying to tell us something this entire time, leaving breadcrumbs across different experiments and cosmic phenomena. And we finally built a microphone sensitive enough, or perhaps just got lucky enough, to hear it. Brian Cox, reflecting on this moment of cross-disciplinary convergence, called it a kind of philosophical checkpoint. Maybe the omega pattern isn't appearing to hand us all the answers on a silver platter. Maybe, just maybe, it's appearing right now as our technology reaches a certain point, simply to tell us we are finally asking the right questions, like a cosmic breadcrumb trail scattered across space-time, nudging curious minds in the right direction. And if nature truly does love a code, like the elegant double helix we discovered in DNA, maybe this one is even bigger. Maybe this one is written into the very geometry and dynamics of the cosmos itself. Because when you step back and look at it, the Omega pattern is challenging everything. Our ideas about fundamental randomness, about simple cause and effect, about how structure even forms in the first place out of chaos. And no matter what specific theory you subscribe to, whether it's a quantum fractal, a universal checksum, an effect of retrocausality, or a cosmic diagnostic, one thing is absolutely undeniably clear. We have just stepped into completely new, uncharted territory. So now, with all this swirling around, the question intensifies. What in the universe are we actually looking at here? The story reaches another peak with the final astonishing convergence. After running for trillions of cycles through Google's quantum core, the Omega pattern didn't just hold stable. As Renova found, it evolved. And the new, complex shape it took on wasn't just vaguely similar to a Calabi-Yau manifold. It looked just like one. A complex, multidimensional geometric shape that string theorists believe is crucial for describing the hidden dimensions of our universe. Those tiny, curled up, spatial dimensions we can't perceive directly. We are talking about the very structures thought to be integral to the deepest levels of reality according to some of our most advanced theories. Now, the truly wild part is this. When the researchers compared the transformed, evolved Omega pattern from the quantum simulations to mathematical models of Calabi-Yau spaces, the theoretical blueprints, the match was almost perfect. We're not talking about a rough resemblance, like two clouds looking vaguely like each other. We're talking about alignment down to a tiny fraction of a percent. The nodal points, the curvature ratios, the intricate structural layout, it all lined up with the theoretical models. It was like the pattern inherently knew where it was going, evolving towards a predicted, fundamental geometric form. And just when everyone thought that was the peak of the strange discoveries, the team made one more comparison. They looked at recent data from LIGO. That's the Laser Interferometer Gravitational Wave Observatory, a monumental experiment that detects gravitational waves, ripples in the fabric of space-time caused by cataclysmic cosmic events, like the merger of two black holes. They took the gravitational wave resonances recorded during one of those massive black hole collisions, the vibrations, the sound of space-time warping, and ran them through sophisticated computational modeling to analyze their underlying structure. And guess what? Those patterns, those echoes from merging black holes billions of light years away, echoed the exact same geometry, nearly identical to the evolved Omega pattern found in Google's quantum lab, which itself matched the theoretical Calabi-Yau manifolds from string theory. So let's break that down, because this is critical. We have three completely different sources: cutting-edge quantum processors simulating the early universe, actual gravitational wave signals from colliding black holes in the distant cosmos, highly theoretical mathematical geometry from string theory describing hidden dimensions, and they all produce the same signature, the same incredibly specific, complex pattern. Brian Cox's reaction to this three-way convergence sums it up perfectly. That's not convergence. That's confirmation. Think about what that means. Across quantum mechanics, the realm of the very small, gravity, the realm of the very large and the structure of space-time, and higher dimensions, the realm of theoretical unification, we are potentially seeing one consistent shape, one repeating pattern. The Omega pattern isn't just an anomaly in one experiment. It's starting to look like the first universal invariant we have ever seen. A constant, fundamental structure that applies at every level, from the tiniest entangled qubit to the largest cosmic collision. The implications here are simply staggering. For physicists, this could finally be the bridge we have been missing for almost a century. A tangible link between general relativity, which describes gravity, and the large-scale structure of the universe, and quantum mechanics, which describes the fundamental particles and forces. Finding a pattern that exists in both realms could be the first real step towards a unified theory of everything. The holy grail of theoretical physics, moving it from abstract equations towards something potentially observable. For engineers, as we touched on earlier, it opens the door to entirely new paradigms. Imagine quantum memory systems that leverage this inherent stability, that literally can't be erased or corrupted, or computers that operate on principles linked to the geometry of space-time itself. These aren't just fantasy concepts anymore. They are potentially within reach. But for the rest of us, the thinkers, the questioners, anyone who has ever looked up at the stars and wondered, this raises something even deeper, something philosophical. If a pattern like this complex, self-organizing, persistent, evolving structure, governs everything from the quantum foam to black hole mergers, then maybe randomness isn't really random. Maybe what we perceive as chance, chaos, or even our own free will is part of a much bigger, much more organized self-regulating system, a cosmic program running itself. And if that's the case, then perhaps, just perhaps, with the discovery of the Omega pattern, we haven't just found a strange anomaly. We may have just read the universe's opening line, the first bit of code in the cosmic program. Looking at this incredible story, from a quantum lab experiment to echoes of colliding black holes, I'm reminded of how much we still don't know. It's easy to feel small and insignificant in the face of such cosmic mystery, but I choose to see something else. I see the incredible power of human curiosity. The scientists, faced with something that defied all expectations, didn't turn away. They dug deeper, they shared their findings, they invited the world to look with them. The lesson here, for me, is about embracing the unknown. When something shows up in your life, your work, your relationships, that doesn't fit the pattern, that feels chaotic or impossible, don't just dismiss it. Ask questions. Look closer. Sometimes the most profound discoveries, the moments that change everything, come from the things that initially scare us, the things that shouldn't exist. According to our current rules, maybe there are patterns hidden in the apparent chaos of our own lives that we haven't learned to see yet. Maybe the universe, on every scale, is just far more complex and beautiful than we ever imagined. This story encourages us to be detectives in our own reality, always looking for the deeper structure, the unexpected connections. So, what do you think about the Omega pattern? Is it simply a complex glitch in our new quantum tools? Or is it truly something way beyond anything we have imagined? Perhaps the universe's signature, its checksum, or even a sign of its own ongoing process? Drop your theory in the comments below. I'd love to hear your thoughts on this mind-bending discovery. And if this kind of science, pushing the boundaries of reality and making you question everything, gets your brain buzzing, please make sure to hit that subscribe button and ring the notification bell. You won't want to miss what's coming next as we continue to explore the mysteries of the cosmos and our place within it.